What is wildcard masking? Wildcard masking is the inverse of a subnet mask. It's used to specify hosts, networks, or a certain range of network hosts similar to what we do with a subnet mask. In this case, block sizes are used to mask these hosts, such as 32, 16, 8, or 4. When you're configuring a mask, you pick the next block size that is greater than the number of hosts you would like to address. When we are using a wildcard mask and you see a 0 in the mask, it means that that octet must match the address exactly. For example, if I wanted to match a host address of 192.168.1.1 exactly, I would use a wildcard mask of all zeros. You can also use the word host, as is shown in the example. Host 192.168.1.1. When you see a 255 in the mask, it means that the octet could be any value. For example, if I want to include any host on the network 192.168.1.0, I would use the wildcard mask of 0.0.0.255. Next, let's examine how we mask a block of addresses with a wildcard mask. Let's use our mask to address the first 50 hosts on network 192.168.1.0. If I was going to put this in an access list, our command might look like access-list 10 deny 192.168.1.1 with a mask of 0.0.0.63. How did I come to this? Well, first, to calculate the mask, we take the next highest block and subtract 1. If we want this mask to address 50 users, the next block is 64. 64 minus 1 is 63. And that's how I came up with the wildcard mask 0.0.0.63. If we want to address 3 networks, the next block size is 4. 4 minus 1 is 3, so our mask in that case would look like 0.0.3 for the 3 networks, and then 255 afterwards so we can address all the hosts. Another way to figure a wildcard mask is that you can subtract the value of the subnet mask that you want to use from 255. For example, if you want to exclude a /25 subnet or 255.255.255.128, you would subtract 128 from 255, which equals 127. In that case, our mask would look like 0.0.0.127. So as you can see, with these 2 techniques under your belt, you'll be making wildcard masks in no time.